Okay, let's see what we get on this one just to see if you're right. Of course, the first thing we see is parentheses, so we're going to have to start there. Inside the parentheses, however, order of operations still applies. So inside the parentheses, what do we have to do? We got another set of parentheses we have to do. 5 plus 1 is 6. So we're going to replace that parentheses with 6. Now that we've reduced it to a single number, we don't need the parentheses anymore. Do we have to put a multiplication in front of it? No, because there's already an operation there. Now I'm just going to rewrite what's in the parentheses because I'm lazy and I don't feel like doing any more. So now I got to do the 2 to the third power, which is 8. What's next? 6 times 8 makes 48. Divided by 12 is 4. Then what? 3 times 8 makes 24. Divided by 6 is 4. And then 13 minus 4 is 9. Plus 4 is 13. Minus 9 is 4. So I've reduced what's in the parentheses to a 4, so I don't need the parentheses anymore. So I got to put in times this time for the 7. So 9 plus 7 times 4 minus 3. And then 7 times 4 is 28. So 9 plus 28 is 37. Minus 3 is 34. So yes, your calculator is correct. Why on earth did we review order of operations? Well, because we use it a lot. It's the heart of a lot of the stuff we do, whether we're using it in forward or reverse. But today what we're going to look at is, oops, anybody still need that for a second? Today what we're going to look at is stuff that looks like this. Evaluate 5d minus 7 over b for d equal 3 and b equal 2. So what would we do? Okay, what we're being asked to do is, this is a generic formula, and we're being asked to replace each letter, each variable, with its assigned value. So instead of 5d, that becomes 5 times 3. 5d is 5 times d, so replace d with 3 is 5 times 3. Minus 7 over b is going to be 2. And now order of operations applies. Order of operations tells us that this line across here, the fraction bar, it does mean divide, but it's also an enclosing symbol. So I have to do everything on top first. So 5 times 3 is 15, minus 7 is 8. Then we can divide by 2 to get 4. Very good. So what we're being asked to do is take the variables and replace them with a numerical value. So we might even have something like this. So evaluate 2p squared minus 4m times parentheses q minus r, close parentheses, plus 1, for p equals negative 5, m equals 7, q equals 8, and r equals 5. I'm going to let you try that in your notes. I'm going to pause my recording for a second here and pass back your tests from last week. So let's take a peek. So this is going to be 2 times, p is -5, so -5 squared. Now you notice I put the -5 in parentheses, because on many of your calculators, it'll have to be in parentheses. Minus 4 times m is 4 times 7, times, and my parentheses will be, q minus r is 8 minus 5, and then we have the plus 1. So what is the first thing we need to do? 8 minus 5, which is 3. Now there's still the parentheses there, but that's not really enclosing. It's just showing us that that's a -5 and not -5. But we do have to work there next because we have the power, the exponent. So -5 squared is 25. Remember, anything squared will be positive. If you don't enter that in your calculator correctly, your calculator will try to tell you that it is negative. Be careful. Next thing we need to do is 2 times 25 is 50. Minus 4 times 7 times 3. 4. What's next? 4 times 7 is 28. Then we have to do the 28 times 3 to get 84. We can't do the 84 plus 1 yet. We got subtractions. We got to go left to right. 50 minus 84 is -34 plus 1 is -33. What do you think? So you guys might be wondering, how does this apply to us? Why do we care? Well, there are formulas all over in carpentry and in woodworking. The biggest area that they apply is in estimating. So we're going to look at some estimating issues or some material calculations. So we're going to look at the base of the house. We're looking at floor systems basically today. If we start out this being the foundation of the house, and let's just say this is a 28-foot by 40-foot foundation. And if we're just going in the order you would build thing, the first thing we would run into are the sills. Everybody know what the sills are? That's just the treated board you put on the top of your foundation to build everything onto. And we're not going to get into, like, a sill seal or anything like that you would want to put underneath it. We're just looking at estimating the board itself. Usually, what's that? The sill seal? Yeah. Well, it all depends on what you use. Some people use a caulking type sill seal. Others use just a roll of stuff that you roll out, the foam type. Yeah.
What's the caulking one?
Caulking is just in a big tube, and you lay down a bead of it. It actually is a better seal, I think, but then if you ever have to lift up one of your sills, it's almost adhered down. Yeah. The only thing with the caulking is you should never have to cut into your seal for a door. Your sill for a door. What's that? Yeah, unless, well, I mean, yeah, your sills you should never have to cut out. The foam pad, of course, I think does a better job of keeping squeaks and stuff out. Although the caulk glues it down, so who knows. We're not going to get into discussing different materials in this class. But yeah. So anyway, the amount of sills is just equal to, and we're going to use S for the linear footage of sills, is just going to equal the perimeter of your building. And of course, perimeter is 2 times the length plus 2 times the width. So if I want to calculate the linear footage of sills needed for this building, it's just 2 times 40 plus 2 times 28. Otherwise known as 80 plus 56, or 136. So 136 feet of sills. Usually you use at least 2x8s, 2x10s, depending on your preference. What's that? This is the basement, the foundation, the concrete. Your sills go on top of the concrete foundation.
Your doors won't be.
Even if you don't have a basement, though, you're required to have a crawl space in most places, unless you're on if you're on a slab. But if you're on a slab, you still have to have a sill on the concrete. So anyway, that is the linear footage of sills required. What would be the next thing we would need? What sits on top of the sills? Not studs, but joists.
Oh yeah,
If you're thinking this is a foundation, we got to have a floor before we can build walls. You're thinking a slab on grade where you're going right into the walls.
yeah. That's what I was.
Our joists now are going to be in two different. Well, if it was a slab on grade, your sills would have to be whatever thickness your walls are. You'd have a 2x6 sill instead of a 2x8. I mean, I've seen people use 2x8 or 2x10 sills depending on their walls.
That's why I was thinking of the doors, the joists.
Okay.
And
That makes more sense, yeah. Now your joists are going to be cut into two categories. Rim joist and structural joists. Because I do engineering, I can't resist doing a little bit of a side note on each of these. Rim joist does not mean that they're not structural. The fact that I said separated that from structural joist. Structural joist just means it has to span a certain distance. Normally, there's going to be some sort of support in the center of this. So let's say there's support right down the middle, dead center. So that means our joists are going to be 14 footers. We're going to assume that whatever we have for a support in the middle there is wide enough that a 14-foot will have enough bearing. Do you guys know what I mean when I say bearing? If I'm looking at this beam here in the center, when my joist sits on it, this point of contact between the joist and the beam, that is the bearing area. We're going to assume that there's enough, that the beam is wide enough that joist can sit on and cause bearing. And we do get an extra 1.5 inches anyway because your rim joist are 1.5 inches or whatever, because your rim joist sits out here and pushes the joist in that 1.5 inches or whatever it is anyway. The joists? Yeah, they sometimes run past like this, and then the ones coming from the other direction will run past this way, and they overlap each other. Now, there is a maximum overlap you want on your joists. Now, sometimes it depends on span. Usually they say 8 inches, 12 inches, depending on who you're talking to. What's that? Yeah, overlap between the joists. The reason for that is if they overlap too much, the floor always sags. Joists will deflect. You're allowed to deflect depending on your structure. Your overall length of the joist, usually it's divided by 240, 360, or 480, depending on your structure. Roofs is usually 240. Floors are usually 360 or 480, depending on whether it's going to be a tile floor or a carpeted floor. Tile floor is usually over 480. Either way, if you have, let's say this is a 14-footer. So let's go over that, just for the heck of it. L over 480. Let's just assume there might be some tiled floors in here. So we're going to design it as strong as we possibly can, as strictly as we possibly can.
So what is the 480?
Well, what is the 480? Well, the length of these are 14 foot, right? Nope. 480 is just a divising constant. 14 foot times 12 would be 168 inches, right? So divide that by 480. That gives you the maximum inches of deflection. So 168 divided by 480 is going to give you 0.35 inches. Now, let's change that into 16ths. Let's go 30 seconds. So multiply by 32, it's 11.2. So that's saying is 11 30-seconds of an inch. That joist can deflect in the middle when it's fully loaded to its allowable maximum load. It can actually sag in the middle. I know this is exaggerated a bit. 11 30-seconds of an inch. Now think about that. If they're overlapping, and this one sags in the middle 11 30-seconds of an inch. So here's our beam. If that joist goes past the beam and overlaps the other joist, if it sags here, what's going to happen out here? It's going to lift up. If this one also sags and lifts up, you got a spot here in the middle where it's actually prying your floor sheathing off of the other joist, and then you get really bad squeaks. You can actually have the floor pop free even. So they limit how much you overlap them so you don't have that. I usually don't go any more than 8 inches. Usually less than that if I can. I mean, I've seen people just take the eye joists, the TGIs, and just run them past and not cut them at all. So I've seen them overlap them like 4 feet, and they always have squeaks in their floor. I've seen a couple where it actually busted through cracked the flooring. So rim joist is just, again, equal to the perimeter. So the linear footage of sills is going to equal your linear footage of rim joist if you're doing rim joist around the whole foundation. When would you not need rim joist around the whole foundation? What's that? You still want to put rim joist around it for the floor. You're gonna have something around the whole foundation. I'm talking about if you have to special order the rim joist, like if you have eye joists. If you're gonna run eye joists across here, you have to have a special rim joist, because an eye joist, a TGI or whatever you want to call them, is not designed to handle what they call a compressive load. So they're just fine when they're spanning. They've got a lot of strength. You can put a lot of weight right here. Where the problem with TGIs or any eye joists is the load right here, right above the bearing where they're being held up. The center web here is not structural for compression. That center web is only structural for bending. So if you put a heavy load right here, it can actually crush that center piece of, that, not plywood even, it's usually just a fiberboard, an OSB. It can crush that. So you use a rim joist around the outside where the walls of your building are going to be. So that rim joist then holds up the wall so that the eye joist itself doesn't get squished. Your rim joist is usually a solid piece, like an LVL type lumber that is exactly the same height as your TGIs. I've seen people try to use like 2x12s for a rim joist with TGIs. Problem is a 2x12 varies in thickness. TGIs are usually 11 7/8, and 2x12s are usually 11 1/4, 11 1/8 to 11 3/8 generally. So you're looking at a 1/2 inch to make up or more, 5/8 of an inch to make up. So you have to either put something to shim the top of it, which is a real pain. So then you would have to separate your rim joist from your structural joists. If you're using just 2x10s or 2x12s for your joists, then you don't need it. Rule of thumb, by the way, for joists, inch of depth for every foot of span. So on a 14-foot span, a 2x10 would not quite be adequate. Some people will design with a 2x10 if you narrow it up to 12-inch on center and stuff like that. Usually at 16 inches on center, it's an inch of depth for every foot of span. What's that? Yeah. So I mean, 14-foot spans usually only like a 13-foot 2 span, really. You still get away with 2x12s. I mean, 2x12s would take you up to like 16 feet. If you got over like 16 feet, then you'd have to bump it up something bigger than 2x12 even. Yeah. 2x12s themselves are heavy enough. I use TG. Personally, if there's the budget there, I'd go with a 2x3 trusses, frame trusses, because then you've got space for all your mechanicals and stuff. You don't have to drill holes through webs. Otherwise, it's all TGIs. But anyway, so if we're doing TGIs, your rim joist is just going to be your perimeter. We also need then the number of joists that you're going to put in here. So NJ stands for the number of joists. is going to be 12 divided by OC stands for on center times your length minus 1. Usually I do each section separately, and I'll show you why. So we have a 40-foot section right here of 14 footers, right? Let's say we're going 16 inches on center. So this is going to be 12 over 16 times 40, then minus 1. Why is it minus 1? Because we don't need 1 on the ends, right? Why don't we subtract 2? Yeah. Because just the 12 over 16 times 40 gives you the final one, but not the beginning one. So you only have to subtract 1. So let's do that out. Punching that in the calculator is going to be 12 divided by 16, and then times 40 is 30. Subtract 1 is 29. So we need 29 of them here, and this is the same length. We need 29 of them there. So we need, for this particular one, we need 136 feet of rim joist, and we need 29 plus 29 is 58 14-foot structural joists, or we'll call them I joists. If we were framing this with 2x12s, or 2x10s, whatever you want to use. I'd use 2x12s on this. 14-foot would be pushing it for 2x10s. The number of joists we would use, we'll still assume 16 foot on center. Again, a beam down the middle. 12 over 16 times 40 plus 1. Why am I adding 1? Yeah, I'm just going to use 2x12s on the ends. So this would be, yes, this still be 30, but it'd be plus 1, so it'd be 31. So 31 here makes 62. 14-foot 2x12s. And we still need rim joist, but we're just going to use 2x12s. We have 40 and 40, 80 foot of rim. Again, just another 80 feet of 2x12s, whatever lengths we have. What's that? That's the 14 footers. We got 14 footers here and here. And that was part of this. That's why we added here. We subtracted 1 because we included this as rim joist. Here we added 1 because we just used our regular 14-foot 2x12 through the ends of it. So that's always the big question: is do we need 1 on the end or not? If we don't need 1 on the end, then we subtract 1. If we do need them on the ends, then we add 1. And then there's some cases where we don't do either. Let's look at that. So let's look at this one. First of all, let's find our missing dimensions. What's this side over here going to be? 28. Very good. How about up here? How about 40? Does that look right? So, how many feet is Sills? Here we can't use the perimeter formula. We just got to add the sides up, and what are we going to get? I'm getting 144. Is that what you guys get? Somebody double check me. Yep, okay. Now here we need to know where the beam is going to be. I'm going to say the beam goes dead center of the 28 feet. So I'm going to go 14 foot to beam from there. So I'm going to run my beam across. So all of these on this side are 14 footers. We also have 14 footers here. Now I'm going to say that what we're using here for joists are 2x12s. So for 2x12 joists, I'm going to look at 14 footers first. So my 14 footers, I have, what's my span here? My length, or not my span. My span is 14. What's my length here that I'm running? 40 feet. So it's going to be, I'm going to go 16 inch on center again for this one. So it's 12 over 16 times 40 plus 1 or minus 1. 2x12 is going to be plus 1. I'll just use 2x12s on the ends, right? So what's that give me? 31. Is there any other place where I'm going to use 14 footers? Right here, right? So it'd be 12 over 16 times 12 plus 1 or minus 1. I need one on this end. Do I need one on this end? Yes, I do. It's going to come out on 12 foot, a 4 foot spacing. It will come out there. There will be one right there. So yes, we're going to add one. That would be just our regular joist. It's okay to be off by 3/4 of an inch. So it'll be off a little bit here. Just when you do your plywood, you either have to put a piece on the side of it to do your seam or adjust your plywood length so that it seams in the center of the joist. So either way, 12 sixteenths times 12 plus 1 is 10. So 31 plus 10 gives us 41 of the 14-foot joists. Next, let's do this section right here. How long do these have to be? 10 footers. Okay? So that's going to be 12 over 16. What's the length that they're going to go? They're going to run 12 feet. Do we need one here? Yes, we do. Do we need one here? Yeah, the answer to this question here is, will it come out right on a joist if we put one there? Yes, at 12 feet it will. It's a 4 foot increment. It's the modular. You're thinking a 4 foot increment. So plus 1. So that's going to come out to 10 again. So we need 10 footers, 10 of them. Are we done? No, we have this section. How long are those going to be? 6 footers. 10 minus 4 give us 6 footers there. Do we need one on this end? No, we've already got a 10 footer there. Do we need one here? No, we've got a 14 footer there. So this is going to be 12 over 16 times 16 minus 1. We don't need one on either end, which is going to give us 11. So 6 footers, we need 11 of them. And for rim joists, if we add up these sides and the top side, it comes to 80 feet. So for the rim joist, I only need these ends. Sometimes it's called an end joist rather than a rim joist as well. In this case, that's all it really is a joist for the end. Now the 80 feet, I'd probably take into consideration the fact that I have 12 and 16. I'd probably just use 12 footers to fill that in. Would work probably the best. Any questions?
So that's just for the rim joist, right?
That's just the rim joist is the 80 feet. So for total, I need 80 feet of rim joists, 80 feet of 2x12s for rim joists. Again, any lengths will do as long as we get our 80 feet. A lot of times your 10 and 14s are cheaper because they're non-modular. They're divisible by 4 foot increments makes modular. Then we need the 41 14 footers, 10 10 footers, and 11 6 footers. Now another thing I'm going to throw in here next is something called bridging. What's bridging? Anybody know what that is? It's in your crossword? Okay. Now you have your joists. There's actually a couple different types of bridging that can happen. There's something called a strong back. And a strong back is just blocking flat like that. That's usually not very effective, but that is how they do trusses. When you have trusses, regular floor trusses, there's actually a spot, there'll actually be a tag on the trusses where it says strong back. You actually run a 2x4 continuously through those, or sometimes they even call for just a 1x4 is all they require. Through those, you have to nail it to the web of the truss at that location, and that causes them to all move together. But what bridging usually is yeah, the X, like this. And that is in between them. Yes. Bridging, now if this is 16 inches on center, that means this distance is only going to be 14 and a half or 14.5 inches, right? Subtracting the 1.5 inch thickness of the joist. The length of that bridging, then depending on the height of the joist, whether this is 12, 2 by 12s would be 11 and a quarter. I joists would be 11 and 7/8 or whatever. Either way, what we do is, even if this is thicker, it could be as deep as 16 inches. We assume the length of the bridging is 1.5 times the spacing. Okay, so that means that since we're going to have a bridging this way and then one this way, it means it's 3 times, right? So for a 16 inch on center, we'd assume it's going to take 4 feet of bridging to do 1x. The way we calculate this is we just look at the amount of bridging is 3 times the length, 3 times L. That is the amount of bridging required. I believe you guys use what, 1 by 3 for bridging or 1 by 4? 1 by 4? I know you're allowed to go down to 1 by 3s, but so you use a 1 by 3 or 1 by 4 bridging material. We need bridging anywhere where the span is 10 feet or more. Depending on who you're talking to, some people say 10 foot does not require bridging. Others say at 10 foot you're required to have bridging. Code, I think, has to be above 10 foot. If it's 10 foot or under, I don't think you have to have bridging in it. You'd have to ask Chris for sure on that one. He'd be able to tell you for sure. So looking at our drawing here, obviously we need bridging here, so there's 40 feet where we need bridging. Here we do, so there's another 12 feet, so that's 40 plus 12. Here we obviously don't. On the 10 foot, should we? Depends who you're talking to, let's put it in. I personally would rather put it in than worry about it later. In fact, if you go over 20 feet, you have to have 2 rows of bridging.
Really, we need more than
engineered joists don't need bridging.
TGIs, yes, they do. Those have to be bridged if they span more than 10 feet. A lot of times for them, what they just do is a block, like the strong back style bridging, like I showed you. 15 and a half inch, you stick it up in there and you pull it down in between and nail through the rod. The problem with strong back bridging on a joist, well, let's do this here first. So we've got a total of 64 feet that needs to be bridged. So the amount of bridging here would just be 3 times 64, or 192 feet of 1 by 4 or 1 by 3 bridging material.
You said if we're over 20 foot, you have to do double. So
Yeah.
Does that mean you have to do double rows on that 40 foot space?
No, I mean over 20 foot of span on the joist.
Oh, over span.
Span. Yeah, it's the span, not the run.
Okay.
So I mentioned strong back. This is not very symmetrical, but yeah, your strong back bridging for TGIs is sometimes done this way. Even with TGIs, it is best to do the X for bridging, but a lot of people just use a strong back bridging where they cut a block. If it's 16 inches on center and a 1/2 inch web, it's only 15 and a half inches, and you just put it in like that. You put a couple nails in from each direction and you're good to go.
Just on one side.
Now you got to keep going all the way across,
No, I mean like on like the top and the bottom.
Usually it's just the bottom is where they put them. Like I said, it is still best to do the X it's still much better to do the X. Now the other problem with the strong back bridging like that is a lot of people screw it up. Here's your top of your joist. They'll put one in here, nail through, then they'll put this one offset so that they can nail through. That doesn't cut it. Again, that OSB in here is not structural from the sides either. It's not horizontally structural. So this could punch right through. They have to be lined up like that. In a lot of cases, if you're going to sheetrock a basement ceiling, that qualifies as your strong back bracing. I would not do that. Code, I believe, in most cases allows you to just sheetrock the ceiling and not brace. I don't like that. Some people will sheetrock right to the bottom of the joist, to the bottom, especially if it's trusses. They'll sheetrock right to the bottom of the trusses. I'm not a fan of that. I would still put in at least a strong back bracing in there. Like I said, the term strong back is used mostly for trusses, where you can just take a 2x4 and take a 12-foot 2x4 and run it right through them and nail it in.
What if you use the property, right? What if you use a trusses?
Well, that's what we're saying is if you're using trusses, you just run that 2x4 through them. The advantage to the X bracing is if the floor joist goes to where a floor joist buckles, it's not because it usually sags so much it breaks. Where a floor joist usually buckles is it starts to sag, and when it starts to sag down, as it's pushed down, it starts to twist off to the side a little bit. That's when it usually will fail and crack and fail. I mean, it's very, very difficult to push straight down on a 2x10 or 2x12 even and get it to bust. It starts to twist and then it'll bust. So the strong back bracing, what that does is it makes it so that if it's going to twist, all of the joists have to start to twist. So it holds it in place. And usually it goes all the way out to the walls where the rim joist should be nailed down to your sill and sealed down, bolted down to the top of your foundation. So it's really tough for the whole thing to move. But the X bracing, what that does is it moves it up to here. So now this cannot twist. It's not pushing against the side of this other joist, which can also move. It's pushing up against here where that joist is attached to the floor. So it's almost impossible. So the strong back is transferring that torsion, that twisting force, is transferring it from one joist to the next until you reach a wall and it's totally stopped dead. Like I said, each joist has some resistance to that twisting. The X bracing transfers that load right up to that joint between the floor and the joist, and it should stop it there. It doesn't transfer any further. So the X bracing is isolating the load on each joist. So each joist is actually braced. I think the X bracing is stronger. It's just a pain. It's more time consuming to install. Very much so. Very much so. And the key to X bracing, I mean, a lot of people think, oh, you put the floor in. Let's put the floor on first. That way we can just, slam this. Oh, come on. Slam this in here, nail it right here. Well, how'd you nail the top? That's what you try to nail through here. But it's a pain. If you do it before you put the floor in, it's a lot easier, I think. But that's my personal preference. Some people just say as long as you nail it here, you don't need to nail it here because it's just going to push into that. And there is some truth to that. But the problem is, let's say this piece falls out. Well, then now this starts to move and it'll pull away. So having it nailed here does help. So.
One of those is got 2 pieces, doesn't it?
Yeah, it's going to be 2 pieces. So anyway, that's bridging. The next thing we're going to talk about is floors. And the floor is just the area of the floor divided by how many square foot is a sheet of plywood, or a sheet of tongue and groove? 4 by 8 or 32 square feet. So you're just going to take your floor area, and I'm going to assume you guys can all find areas by now, and divide by 32 square feet per sheet. Now I realize we covered a lot of stuff today. So I'll let you guys get started. I'm going to hand out a packet to you. In the packet, it is going to be page, where'd you go? On page 237, it's asking you a question. There's going to be a girder buildup too, which we didn't really discuss. But on page 237, there's problems 1 through 3. The big ones, problem 3, there are foundations or outlines of foundations on page 238. And so for each of those, I want you to give me the linear footage of sill, the length and number of joists, just the linear footage of bridging material, 1x4 or 1x3, and the number of sheets, 4x8 sheets of flooring. I'll leave that up there while I pass out the packets. You guys get all that down?